Okay, welcome back. We got our chapter 3 solving quadratic equation notes and our beautiful mahogany desk, which is 100% real mahogany. Totally not fake. So this is a 3.1. We're going to do a bunch of review from grade 10 and then we're going to dive into the grade 11 material. So I might not do all the review, but the most basic kind of polynomial you have is this form here, ax squared plus bx plus c. So these are the letters we use. The a is always the coefficient of the x squared term, the b is always the coefficient of the x term, and then the c is the constant term. So when you have something like this, you're looking for two numbers that multiply to negative 21 and have to add to negative 4. Okay, so we know that it's going to look something like this. Two x's, we know we're factoring it, so two numbers that multiply to negative 21 but add to negative 4 might be negative 7 and positive 3, and that's factored. Now we got a bunch of different special cases. I'm gonna see which ones kind of stand out to me here. Let's see, well, this first one, always check and see if there's a greatest common factor. Okay, so this one has a greatest common factor that you can pull out right away. I'm gonna just do it over here. You can pull out a 3 and make it into a regular trinomial where a equals 1, and actually that's what this was over here. This was an a equal 1 type factoring question. So now I just have a 3 in front and I could go ahead and factor that. And this next one here, this is a decomposition, so we'll actually review that on the next page. That's a longer process, but you'll get very good at it this year. This one, it looks like there's a greatest common factor. It looks like we can pull out a 2 and then we'd be at a similar stage there. This one right here, this is the perfect square trinomial. Should say square in here. Let's just write a square. Perfect square trinomial. So really quickly, if you don't notice that a trinomial is a perfect square trinomial, it's okay. You'll just end up doing decomposition and taking a bit longer. But if you do notice it, there's a few things to notice. That number has to be a PS. That stands for a perfect square. And this number needs to be a perfect square. Okay, so 9 is a perfect square, as in I can do the square root of 9, I get 3. I can do the square root of 4, I get 2. But there's one more condition. When you go 2 times whatever you get by doing the square root of this, which we got 2, times whatever you get when you do the square root of that, you should get this coefficient here, the 12. And also you should get the same variable. So when I did the square root of this, I should have done the square root of 9b squared, and that would have given me 3b. So this would have been a 3b, and when I go 2 times 3b, I get 12b. So that's a perfect square trinomial. If that's the case, what you're going to do is you're going to take whatever the square root of this is and put it in here. Then we're going to go 3b and 3b over here, and then you're going to take the square root of this term, the c term, and you're going to write 2, and then as far as the sign goes in here, you just want to make sure that you match whatever sign is here. So if this is a positive, you're going to put a positive there, and that's a perfect square trinomial. You've done factors. I'm not sure what I just said there, but I meant to say you factored it. A difference of squares. So up here, this last one is a difference of squares. So I'm just going to recopy it here a little bit bigger. It is m squared minus 16n squared. So a difference of squares, there's a couple things. It's a binomial, which means there's two terms. There has to be a negative sign in between the two terms. And the last thing to check is both terms are perfect squares. So both terms are, I'm just going to write perfect squares. So in this case, m squared is a perfect square because I can go and do the square root of m squared and get m. We generally call this a, not to be confused with, where is it? Not to be confused with the coefficient of the x squared term. Just in our formula, we call this a. And if I can do the square root of that, we call that b. So 16n squared, well, that equals 4n. Okay, so b is 4n, a is m, and the formula for a difference of squares is a minus b times a plus b. So that's how it factors. So my a term is m, so I'm just going to write m minus, and then b is 4n, like that, and then same thing, just with a plus sign in between, and that's how you factor a difference of squares. All right, so that's a quick review. If you need more, you need to come see me, or maybe just do some practice on your own. Okay. we're going to quickly review decomposition. So decomposition is when the a term does not equal 1. Okay, so when the a term is not positive 1, and it's not one of those special cases, you are going to have to use decomposition. Okay, it's just an algorithm. You can get very, very quick at it. You don't need to show a lot of work. I'm going to do this in detail, and then in class I'll talk about how you can really do this quite quickly. You can get very, very fast at this, and there are other ways of doing it. This is just the method that I prefer, so if you have another way that works for you, keep it. Yeah, don't change. Don't change if you can help it. So basically what we need to do is, if we're going to factor this one, the algorithm is you're really looking for two terms or two factors that multiply to a times c. And that's the same as the when a equals 1 algorithm. So the only thing is that when a equals 1, so I'm going to go back here for a second. So in this one, the a term here is a 1. So when we go a times c, it's still negative 21. But when it's not equal to 1, well, a times c is 12. Okay, so what I like to do is I like to make a little table to keep track. So we need two numbers that multiply to a times c. So in this case, a is 3, c is 4. So we're looking for two numbers that multiply to 12. And then they have to add up, as usual, to the b term, which is positive 7. So if you make a little table, you can keep track. Now, 3 times 4 is 12, and that adds to 7. So I found my two factors. Now, when you get down here, right, I kind of mentioned here it's decomposition because we're gonna end up rewriting this middle term. Okay, so when we rewrite it using our two factors of 3 and 4, we write 3x squared, so that's the first term. The 7x we break into two little pieces. So we break into a 4x and a 3x. Now the order you write these in doesn't actually matter. The algorithm will still work. But if you can, you'll notice that these first two terms, they both have something in common, like they have a greatest common factor that isn't 1. And same thing with these ones. So when you do write them down, I do recommend that you think ahead. It just makes it slightly easier. Okay, so just double check. 3x plus 4x is 7x. So we're on the right track. Now what we're going to do is we're going to group the first two terms. So we're going to look at just the first two terms and we're going to pull out the greatest common factor. Okay, so the greatest common factor here is a 3x. So greatest common factor is a 3x. So what I do is I pull out a 3x, and if I redistribute it back in, I would get 3x squared. 3x times 1 is 3x. So you're just pulling it out. Okay, you're going to do the same thing for the last two terms. So the last two terms, greatest common factor is a 4. So when I pull out a 4, I'm going to get x plus 1, and here it is down here. Okay, now we're basically done. So the algorithm works like this. If you did it correctly, the two binomials should be matching. Okay, and they're both x plus 1. Okay, so I just say notice the parts in the brackets are both the same. Okay, and to factor it, what we're going to do is we're going to take one of these brackets, and that'll be one of our binomials that are factored. And then the other two numbers, the outside numbers, the 3x and the 4, we put them together in a bracket. So this is how the factored form of this trinomial, where did it go? Yeah, over here, this trinomial looks like. Okay, so that's decomposition. Again, something you did in grade 10. If you need more, you're going to have to practice or come see me. All right, so we're going to do a couple of questions. So is x plus 3 a factor of each trinomial? Well, there's an easier way to do this in grade 12, but basically in this one, we're just going to factor them and see if it works. When I say see if it works, I mean, is x plus 3 actually a factor? So when we factor this one, and I'm just going to do one of these because I'm trying to keep these notes brief. So let's go ahead and we'll do this one. So I check, is there a greatest common factor I can pull out here? No. So I'm going to have to do decomposition. Okay, so I'm looking for two numbers that multiply to a times c, which in this case is 4 times 9, which I'm going to have to think here is 36. The two numbers that multiply to 36, and they have to add up to the b term, which is 12. Okay, my table's a little messy here, but that's fine. Okay, so what are my two numbers? Well, 1 and 36 don't work. Maybe 3 and 12, no. 4 and 9, no. I hope I don't have to pause the video here. I'm just gonna have to write them out. 2 and what, 18? Getting closer. What else did I say? 3 and 12, not quite. Obviously 4 and 9, but we're not quite there. 5 doesn't work. 6 times 6. Perfect. Oh my goodness, this isn't a decomposition. This is actually a perfect square trinomial. So then that can happen. I totally did that on purpose. How did I know this is a perfect square trinomial? Well, this is a perfect square, that's a perfect square, and very likely when I check it out, I'll probably get that middle term. So if it's a perfect square trinomial, all we need to do is figure out the square root of 4x squared and the square root of 9, so that's 3, and that's 2x. And remember, when we multiply these together and multiply by 2, if it's a perfect square trinomial, we should get that. So 2x times 3x is 6x times 2 is 12x, so yep. So all we got to do is write our brackets and put those two terms together, 2x. To get the sign, just look at the sign here, so it's plus, so I put a plus there. So 2x plus 3 times 2x plus 3, and we're done. You'll just have to believe me that it works. You can always factor it out and try. You can also write it like this. Okay, we will do this one. This one is not a perfect square trinomial, so this one is a decomposition. So we're going to make our little table. So it's got to multiply to 2 times negative 15. So negative 30, and it needs to add to whatever this is. So adds to 1. So yeah, whenever it adds to 1, your two factors are going to be 1 apart. So 6 and 5 multiply to 30, and they're 1 apart. Now I need to be negative 30, and I need it to be positive 1. So it's going to be negative 5. Okay, so I'm going to recopy. I'm going to go 2x squared. I'm going to rewrite this middle term using these two numbers. Now, 6 has a greatest common factor that's bigger than 1 with 2. So I'm going to go plus 6x and then minus 5x. Okay, and then subtract 15. Always double check. When you add those up, do you get positive x? If you don't, something's wrong and you need to check it out. And again, the order you write these in doesn't matter. Your work will look different. You'll still get the same answer. It'll be slightly more weird. Look at the first two terms. What's the greatest common factor you can pull out? It looks like it's a 2x. So you pull out the 2x and you get x plus 3. And then look at the last two terms. Well, I can pull out a negative 5. That gives me x plus 3. So if these two things match, you're done. All you got to do is grab those two numbers, slap them together like this, and you're done. You factored it. Beautiful. Yay. Oh, we never even answered the question. So is x plus 3 a factor? Well, in this one, yes, it is. So the answer is yes. This one over here? No. Silly me. All right. What's next? Okay, so now we're moving on to the grade 11 stuff. So basic factoring stuff that we learned in grade 10 basically applies. We're just going to throw you a couple curveballs. So honestly, I don't know why we're so obsessed with factoring in Manitoba. I think once you know the basics, you can really just use a computer program to do it for you. But here we are, factoring stuff like this. So if you have a decimal, okay? So if you have a decimal, right? Like I got a 1.2. That is, weird. What's the strategy? So the strategy is multiply. So strategy. You're going to want to multiply by 10 as many times as you need to get rid of all the decimals. Okay, so in this case, I got a decimal here and a decimal here. If I multiply this whole thing by 10, then that would completely remove the decimal. Now, let me write down the strategy. So multiply by 10 as many times as you need. You have to keep track of how many zeros you have, as many times as you need to get rid of the decimals. Okay, now you can't just change the question. Like if I multiply everything by 10, it's a new question. So you need to set up a factor in front of the whole thing that actually brings you back to where you started. So once you find out how many zeros you have, you will then you'll go 1 over that number. So for example, for this one, I'm going to multiply everything by 10. So I'm going to go ahead and do that. So if I did that, I would get 10x squared plus 14x minus 12. Okay, now I've clearly changed the question. So what I do is I put brackets around the whole thing. And to get back to where I started, I just go 1 over 10. Okay, so if I had to multiply this thing by 100, I would go 1 over 100, and in here I would multiply each term by 100. If it was 1,000, same thing, I'd go 1 over 1,000. So what this does is, when I distribute this into the brackets, I would get back to where I started, and I haven't actually changed the question. But the neat thing is hey, now I know how to factor that. That looks like a decomposition question. Also, it looks like I can pull out a greatest common factor. Okay, so this term out here might get changed, but it looks like I can pull out a 2, right? So I pull out a 2, so I'm just gonna write 1 over 10, and I'm gonna write another bracket. I pull out a 2, and I'm gonna get 5x squared plus 7x minus 6, okay? And then 2 times 1 over 10 is 1 over 5. Excuse me. So now this thing looks completely different, but if you were to work it out, if you were to multiply this all out, you would get back to here. Okay, now I know how to do this. This is a decomposition question. Okay, now the purpose of my notes, at least these ones on YouTube, I'm trying to keep them short. I am not going to do this decomposition. Okay, if you need to practice decomposition, you're gonna get it in the homework. So I just want to show you, well, that's the new thing, and then at this point you use decomp and you keep going. Now, what happens if you have something like this, something with a fraction? Okay, you could change it to a decimal. But you may not have a calculator, right? We're trying to get you ready for a no calculator lifestyle. So in this case, it's very, 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 very similar. We just need to multiply by the lowest common denominator. So if you have more than one fraction, in this case, we just have divided by 2. So I'm going to multiply everything by 2 to get rid of it, okay? So, and again, you need to do that factor out in front. So if I multiply everything by 2 out in front, I need to put a 1 over 2. Okay, and multiply everything by 2. So you would get 6x squared minus 29x, right? If you divide by 2 and multiply by 2, you're just going to be left with the numerator, plus 28. Now, if you were to bring the 1/2 back in, well, half of 6 is 3, and then half of negative 29 is 29 divided by 2, and half of 28 is 14. Okay, so now you're back to something that you can factor. This looks like a decomposition question. Is there anything we can pull out? 3 doesn't work. So no, this is sort of a really ugly question. It'd be really big numbers. It can happen. Honestly, on the test, I stay away from having gigantic numbers like 6 times 28. That's a really big thing to look for. But yeah, you would use decomposition from this point forward. So I would say check the exercises. There are some try it yourselves. If I was in class, we would try one, but not. Next, we will replace the variable in the trinomial with an expression. Ah, yes. So this is a substitution type question. So if you want to write substitution, I can't spell substitution question. Okay, so this is where, this is a regular question, but what happens here is now we have an x plus 3 and an x plus 3. So when there's a common element, a common binomial, this would be really hard to factor. I would have to expand this out, distribute this in, and then combine all the terms. Sometimes it's faster just to pick a variable as a stand-in. So the substitution question involves choose a variable to stand in for usually a binomial, Could be a trinomial, but I don't think we go there for a binomial in a factoring question, for lack of a better way of describing it. Okay, so what we're going to do is we're going to factor this one, and you'll see why in a second. This is just a regular, good old A=1 type factoring question, so we know it's going to look like this. Okay, 2 numbers that multiply to negative 16, but add to negative 6 would be negative 8 plus 2. So that works. Now, check this out. So what's the giveaway? The giveaway here that I have to use a variable is like, well, I have an x plus 3 and an x plus 3, and that's a binomial, and it's all throughout. So for part B, I'm going to do it down here. You do need to make the statement. You need to say, like, let, I don't know, A be x plus 3. That's horrible. Let A be x plus 3. And then you can recopy this. So if A is x plus 3, then I really just have a squared minus 6a minus 16. And hey, look at that. It's now question A again. So what's the answer? The answer was x minus 8 and x plus 2. Now, I called it A. So I will write A minus 8 and A plus 2. Now, am I done? No. I said a was x plus 3. So to be completely done, I need to re-plug in, for a, I need to re-plug in x plus 3. So I'm just going to write resub for a. Okay, so that means I'm going to take the x plus 3, I'm going to pop it in wherever there's an a. So I have x plus 3 minus 8 times x plus 3 plus 2, and then clean it up. You know, group any like terms, so you get x minus 5 and x plus 5. And you might recognize that as a difference of squares. So what that means is if I had factored this all out, I would have ended up getting a difference of squares, but I was lazy and did it this way. All right. Now, for C, this is just a longer question. The reason being is that the binomial is a bit more complicated, like it has a coefficient in front of the x, and then there's a 6 here. So same idea though. You're going to say let a be 3x minus 4. Now I'm not going to do this whole question, but I will get it started. As at a certain point, it just becomes something that we did in grade 10. So wherever there's the 3x minus 4, you're going to go 6 times a squared minus 21 times a plus 15. Now, if there's anything you can pull out, like this looks like a decomposition question to me, but I am noticing that 6, 21, and 15 will have a greatest common factor of 3. So I'm going to pull out the 3. Now, if you do that, if you don't notice that, it's fine. You're just going to have bigger numbers and maybe a more complicated question. At this point, it's a decomposition. I suppose we'll do it for practice. Also because I want to show you what happens. So decomp, we're looking for two numbers that multiply to a times c. So it's going to be 10, and they have to add to negative 7. There's not very many options. 1 and 10 don't work. 2 and 5 work. I need to get negative 7. So they're both negative, and that way they'd multiply to positive 10. So I'm going to show you also the fast way of doing decomposition. So I'm going to recopy that middle term. I'm going to write minus 2a minus 5a plus 5. Okay, and I'm going to skip the step where I write down like what I pull out when I do the first two, when I do the greatest common factor there and the greatest common factor there. So I'm just going to look here and I'm going to say, well, I can pull out a 2a. So I'm going to write 2a in that bracket. Okay, the other bracket should be what you get when you actually pull out the 2a. So when I pull out the 2a, I would get a minus 1. So I write that there. Now I look at the last two terms. I need to get a minus 1, so I need to pull out a negative 5. So remember, that would be the outside number. So I'm going to write it in there, and I'm going to double check. Do I get a minus 1 when I pull out the negative 5? The answer is yes, so you factored it. Now you resub for a. Okay, so a was 3x minus 4, so in here, you're going to pop in 3x minus 4. Use brackets because you have a 2 here and you need to distribute it into the brackets. So this is about as ugly as it gets. Didn't use brackets here because there was no coefficient. Okay, and then you just clean it up. I suppose we'll finish. So I'm going to get 6x minus 8 minus 5, and I'm going to get, 3x minus 4 minus 1 is 3x minus 5. Clean that up. Oh my word, what do we get there? Very messy question, but there it is. It will never get worse than that, I promise. Okay, last thing. Grade 10, you learned to factor a difference of squares. In grade 11, we use the same factoring pattern, but replace the variables with expressions. So again, we're gonna look at this, and we'll see how b actually becomes the same as a. So all this is we have to do a substitution twice. So this is really complicated, right? And we have different variables. So we wouldn't be able to factor this regularly, but we can use substitution again. We're going to use substitution twice because we have two different binomials. Okay, so this is a difference of squares. You would get x minus y and x plus y. Over here, I'm like, oh, well, it looks like a difference of squares, right? Like it's like something, this is a perfect square, that's a perfect square, it's a binomial, there's a negative sign, but it's complicated. So I'm going to say let a be 2x minus 1 and let b be the other thing. And then you can rewrite this as a squared minus b squared, which is the same as over here. I should have probably used the x and y, but I didn't. So now I can factor this. I know it's a minus b, a plus b. And then, got to resub. So wherever I see an a, I'm going to write 2x minus 1. Wherever I see a b, I'm going to write y plus 4, and then I'm going to clean it up. So yeah, it's going to be a nightmare. But isn't that just life? Now, when you have I got the negative here, so make sure you use brackets when you plug b in there. And then a is 2x minus 1, and then plus b, which is y plus 4. Okay, so I'm going to clean it up, bring the negative in. I'm going to try to clean it all up at once. I'm going to get negative y, and then I'm going to get negative 1 subtract 4, so I'm going to get negative 5. Now, you can't group those, so obviously you're going to leave it like that. And then here I'm going to get 2x plus y. So you'll notice I'm writing my variables first, and then I'll write the constant term, and then I get plus 3. Okay. So that's what it factors to, and obviously you would have never been able to do that very easily, but because of the power of the double substitution, you certainly can. Now this question is just a little bit longer. For the sake of keeping this video short, I'm going to leave it. It's exactly the same thing, it's just now you have some coefficients, so I'll leave it as a bit of a challenge. There's certainly something like that in the homework. Okay, so you'll be working on the next exercise in your exercise book. Make sure you're doing your homework because this is something you need lots of practice on. Okay, bye-bye. See you next time.